Hi, many people have asked what exactly it is that we're doing at PK Data to try to help you with your data. And I thought the best way would be to show an example of what we can get out of just a simple GPS speed channel using, in this case, it was an AIM MXK10 on a ZX10 that Eric Wood rode in 2021, actually, sorry, at the end of 2020. And I bought in early 21. So we had some data left over. His was from 2020, mine is from 2021. But as an example, since we're using the same map, we can overlay the data. And we'll be able to show a couple of the features that we can look at and how we use this to make riders better riders. So if you look at the screen, what we see here is a very simple layout that is a portion of New Hampshire Motor Speedway. I've already done a bunch of work in the background to get this ready to go. And what we're looking at is just one channel and 2 laps. So the one channel is GPS speed. If we click over here in the upper left corner under channels, you'll see that the only one enabled here that's flashing around is GPS speed. And what AIM has done, when you have 2 sets of data, it automatically assigns the color per lap so that you don't have a mess of colors on the screen. And if we click on the laps channel, then you'll see which laps that we are analyzing. So up here, again, Eric's best is 111.884. And we're overlaying my best, which was a 17.025. So my lap is in blue and Eric's lap is in red. As you can see, the speed traces here. So there's a couple of interesting things. Like most of you at this point have downloaded maybe some of your lap time data and looked at your split reports, and you've seen theoretical best rolling laps and best laps. And then maybe you've looked at some of the GPS data like what we have over here on the right side of the screen, which has combined some sections, and this shows a bit of the racetrack. But you probably haven't really analyzed what's happening with the other speed channels. And of course, any of the GPS lap timers have a speed channel, and you can do this analysis in several different ways. And this, again, I'll help you try to work through it. It's easiest if you use the same system and the same maps. It gets more difficult if you don't, but sometimes the data can be combined. So let's just take a look at what we see here on the screen. This main part of the screen here in gray is the time distance view. So we are in distance at the moment up here, which means that these numbers down at the bottom are feet from start finish. That's the most common way to analyze your data, is the distance from start finish, because it changes very little. Time, however, changes a lot. And you'll see how these things vary, not just where you're on the racetrack, but when you are where on the racetrack when you switch, which we'll show in a little bit. So the first thing that we see when we look at these 2 graphs is that for the most part, the red line is above the blue line. And since speed goes up the left side of the graph here, GPS speed, that means that the higher the line, the higher the speed, which you would expect from someone doing a high 111 versus a 17 flat. So basically, we're looking at roughly a 5.2 second difference in lap time. So you certainly would expect that. But if we look a little deeper into the data, there's a few things that you can see going on. For instance, there's a couple of places where the blue line here is higher than the red line. And over here, we see the same thing. And here, we look at where the peaks are. We have a peak in the blue line here and a peak in the red line here. Also, I want you to notice that when we drag the cursor, okay, that the red line is more peaky, more of a sharp curve, and the blue line is less of a sharp curve. And that shows the change in speed. And we can look deeper into accelerometers later on. But let's just look at one simple function that it has here. And this is the delta function. And delta means change in, for those that don't know what it means in engineering. Delta is the change in speed, the change in time, the change in something over something else. So with the delta function, if we just put the cursor here and we look at this 2 speeds up here in the upper left-hand corner, my speed's 112 and Eric was 119.7 for just about an 8-mile-an-hour difference. But there's something else that very interesting that happens here. If I click on the delta, and then I pick my second point here, now I'm getting changes in speed over a distance, and that's reflected up over here, where we have the change in speed over the distance. And you'll notice that my speed went minus 3.1, minus 6.5, and Eric's went up 1.4 and up 3.3. So we have quite a difference in speed between the two. Whereas now at the second point here, I'm at 109 miles an hour in round numbers, and Eric's at 121. So before we only had a few miles an hour, we unclick the delta function, and we go back and we look at my peak. We had 112 versus roughly 120. And at this point, we had 109 versus 121. And if we again click on the delta and go back to my peak approximately, we see the differences in speed there. So at a time, and you look at the difference between the two lines, where I'm slowing down, Eric is still on the gas and accelerating. So we not only have a difference in speed, but we have a difference where Eric is gaining speed, where I'm losing speed. So now we can see very clearly where I need to improve on the racetrack. And if you look over on the track map over here, you'll see that there are two dots there. They're hard to see, but it's overlaid. We'll try to zoom in a little, and you see that we've got two dots next to each other. And that's because we are in the distance function. So the data is taking at a distance from start finish. If I click on the time function, it's now going to show you the split between the blue dot, which is me, and where Eric is, and this is on time. So at the same time from start finish, Eric has what looks like probably 4 or 5 bike lengths on me. And at that point, that is where he is just starting to decelerate, whereas I have already decelerated. We unclick the delta function and click on the map. We'll see here's where my speed peaked, and we'll click on Eric's peak and see where his speed peaked. So he's still accelerating and you can run the delta function here in feet and figure it out, but it looks like he's got about another 15 or 20 yards or so of acceleration over me. So when I look at this now, I know that the next time I go to this racetrack that I can go deeper, but I can also look at the GPS position on the map and pick up a marker and have something to shoot for to try to hold the gas on that far. So even though the whole time I'm going slower, at least if I can begin to get to rolling off at the same point that he is rolling off, that would be an improvement in my lap time because I would be going faster for longer instead of slowing down sooner. Then there's another thing that we can look at over here at the bottom of the peaks on both of them, especially over here. And when you double click on a part of the map, you'll see that AIM puts you right on the racetrack on the section that you're in. We're going to go back to distance for a moment and start there. And we'll zoom in on that section of the racetrack. And this is the exit of turn 2 right here. And there's something that we should notice, and that is that my speed bottoms out at the slowest point here at about 50.4 miles an hour. And at the moment, Eric is still decelerating as I begin to accelerate. So if I use the arrow cursor, we come together right about here. You'll see our speeds match, and we are at just slightly different places on the racetrack. But notice that Eric still decelerates, where I am now beginning to accelerate. And you ask, well, what's going on here? If I got on the gas sooner, why am I not going faster? And the answer is quite simply, we're riding 1000s, except I'm riding it like my SV, where I have turned the gas on too soon and have been unable to finish the corner and then get on the gas harder later, which means I was on the edge of the tire longer. And if I just keep cycling through, you'll watch the dots on the map cross. And you'll see that Eric then is on the inside, and he's got the thing up and running harder and faster than I do. Then if I switch to time mode, we'll see just how far ahead he is after the drive. And we'll have to zoom in on it. Right here, and it doesn't look like much because it's not a lot, but it is a couple of bike lengths at that point in time. And when we fast forward to the speed peaks, he's gone from 1 or 2 bike lengths to approximately 10 or 12 before he rolls off. And that's a way that we can use the GPS speed channel here to identify not just how fast we're going, but where we're going fast, when we start to get on the gas, and how that affects the speed later in the lap or further down the straightaway. The same thing occurs again when we get a little further in that section down into turn 3. We zoom out and have a look and click on the data. You'll see that Eric is quite a bit ahead of me on the 2 dots on time. If we look at it in terms of distance, when we're at the same point on the racetrack, up here in the upper left, you'll see that our speeds are fairly similar at the moment. And for a little bit, again, I'm faster than Eric. The problem is I'm going too fast, can't finish turning the motorcycle, which means that as soon as we begin to accelerate here, he's now pulling out an advantage. And by the time we get further up the road, he's quite a bit further ahead. To get if we go back to the time function, then you see what a difference that just delaying getting on the gas makes. Sorry about that. What a difference delaying getting on the gas makes between me being here because I'm still turning it on the edge of the tire and Eric being all the way here at turn 4. And exiting it on the fat part of the tire and driving hard. So when you're wondering, why do we need to analyze data? How can we do it? Aren't lap times just good enough? This is how we can pick apart one channel in one section of a racetrack and really analyze what am I doing differently that's costing me some 6.2 seconds a lap or whatever it was, but 6.2 seconds a lap or so versus 5.2 versus what Eric's doing. And at most tracks, every second is approximately 1 mile an hour. So our average speed difference only different by about 5-6 miles an hour. But this is how Eric's able to do it versus how I'm not able to do it. And the short answer is I'm not riding the bike correctly. And this is showing me exactly where and why and how I'm going wrong. So I hope you guys enjoyed the video and was informative. This is what we're looking at doing with PK data, getting you guys to use this data, getting you to actually analyze it more than just looking at your theoretical bests, and actually making better riders out of you by using this data with your coaches and your coaching in order to advance your skills. Thanks for watching.